Okay, yesterday, we were solving log equations toward the end of the class. And basically, we are trying to use this fact, okay? So, so notice the difference between this kind of problem with these, okay? So basically, what's the difference? On this problem, we only see logs on the left-hand side or the right-hand side, okay? Whereas here we see logs on both sides, okay? So what's the point, basically? So here, what we want is we want to have a single log on each side with the same base. Then we can just cancel the log A, and then we'll have this m equals n stuff, okay? So in particular here, we can combine the two logs on the left-hand side into a single log by using the multiplication, and then we can cancel the logs right away, okay? And then we have 2x squared plus x equals x plus 8, and then we solve it. And then remember, once you get two values for x, you must check whether both work or none of them works or only one of them works, okay? So here, we got that -2 doesn't work, so the answer is just 2, okay? So remember that please do not assume that negative number is always out and positive number is always in, okay? It might be the opposite, okay? And both numbers might work and none of them might work. And if you get like two positive numbers or two negative numbers, then you don't know which one works and which one doesn't, okay? So you have to explicitly double check. Okay, so now continue. Log 2, 5x minus 6 minus log 2x plus 1 is log 2, 3. Okay, so again, once again we see the two logs on the left-hand side, okay? So that means if we want to combine the logs on the left-hand side, now here we see subtraction, right? And what does subtraction mean? So subtraction will turn into division, right? Remember that? Okay, so product turns into addition, okay? And then the quotient turns into subtraction, right? Okay, so subtraction turns into the quotient or fraction. Okay, so we have log 2 and then 5x minus 6 over x plus 1, right? And then is equal to log 2, 3. Okay, now at this point, can we cancel the logs? Yeah, right, because they have the same basis, right? Okay, so we have what? Just 5x minus 6 over x plus 1 is equal to 3, right? Okay, and now the question is, how do you solve this equation?
Multiply both sides by x plus 1.
Right, so we have a fraction, so we have to somehow remove it, and that means we need the LCD. So here LCD is x plus 1, so oops, x plus 1. So we need to multiply x plus 1 to both sides. So what does that mean? Times x plus 1 times x plus 1. So these two cancel. And so we have just 5x minus 6. And then the right-hand side means 3 times the quantity x plus 1. Okay, so we have what? 3x plus 3, right? Okay. Okay, so what does that mean? So subtract 3x and then add 6. Okay, so cancel. So 2x equals 9. So x is equal to 2 over 9, right? Okay, and since we got a single number, that should be the answer. Okay. And now, C. So log 8x plus 2 plus log 8x plus 4 is log 824. Okay, so this time we have a summation. Okay, so this means sum turns into the product. So what do we have? Log 8 x plus 2 times x plus 4 is log 824, right? Okay. So now what do we do here? So now we must FOIL this, right? Okay. So what do we get? Log 8 and then x squared plus 4x plus 2x. So that means plus 6x and then plus 8, right? And then log 824. Okay. Now, remember from yesterday's class, if we didn't have log 8 on the other side, then what do? You do the conversion, right? Like 8 to the power 24 will be equal to this, right? Okay, but here, since we have logs on each side, what do you do? With the same base, of course, you just cancel them, right? Okay, so you have x squared plus 6x plus 8 is just 24. Okay, so now this is a quadratic equation. So that means what? X squared plus 6x, and then you move 24 over. And then what does that mean? Minus 16 equals 0. Now, can you factor the left-hand side? Yeah. So what times what?
8 and 2.
Right, plus 8 and negative 2, right? Okay. So x plus 8 and x minus 2. So x is equal to negative 8 and 2, right? Okay, so now, are we done or do we have to check? Check, right? Yeah, because we got two numbers, right? Okay, so check. So first, negative 8. So remember, we plug each value into the original x right here. Okay, so what do you get? Log 8 and then negative 6. Now, is that good or bad? That's not good, right? Remember why? Because we cannot have negative number inside each log, right? Okay, so we don't need to go any further, right? Because this one is already bad. Okay, like we don't care what happens for the other terms, right? Because we may or may not see the positive numbers for the other logs, but this is already bad, so that means that guy is bad, right? Okay, and now for the other number 2. So what do you get? Log 8 and then 4. Okay, so that's good. And then plus log 8 and then 2 plus 4, so that's 6. Okay, so that's good as well. So what do you notice? So since these are good, this is also good, right? Okay, so what does that mean? This is the answer, right? Okay, so when you get 2 or even more values of x, then you must check. But in general, if you get one number for x, then you don't have to check. But remember, that's not always the case. But 99.9% of the cases, that will be it. Okay, so you don't have to double check. Okay, so now let's do 3 more problems. Okay, so now we will apply all of these. So first, solving for a specified variable. Okay, so remember, what does it mean? We will see multiple letters, and there will be an assigned variable that we have to isolate, right? Okay, now, the thing is, these problems tend to bother people because one, well, exponential and log equations are themselves tricky, but not only that, there are like 1,000 letters for equation, so that kind of bothers people. But let's see what we have learned, or like how much we remember what we have learned yesterday. So part A, t equals a plus c e to the kt, and solve that for k. And where is k? Right there in the exponent. Okay, so this means isolate k. Okay, so that's obvious. Now, what is the first step to isolate k?
Subtract A.
Minus a first, yes. Okay, and what's the reason? So this k is contained in ce to the kt, but there is something else in front. Okay, so we first have to move a over. Okay, so minus a first. Okay, so what do you get? T minus a is equal to ce to the kt, right? Okay, and now, can you see what the next step is to isolate k?
Divide by C.
Divide by c, yes. Okay, and what's the reason? So notice that this is kind of similar with this kind of equation, which we have seen similar equation like this yesterday when we were solving exponential equations. So what do you have to do? Isolate the exponential term by itself, which means divide by c. Okay, so we get t minus a all over c is equal to e to the kt. Okay, good. And now, what do we do next? So, for example, for this simple problem, when you divide everything by 2, you get 3 over 2 is equal to e to the 4k. And now what do you have to do? So again, k is in the exponent, which we want to isolate, right? So how can you somehow bring down the exponent? What is the only way that allows this to happen?
Take the log.
Take the log, yes. Okay, log is the only tool that allows us to move the exponents, right? Okay, so take the log, and in particular, which log? ln. Okay, so what does that mean? ln t minus a all over c is equal to ln e to the kt. Okay, so now simplify this right-hand side. ln e to the kt. What's that equal to?
It's just KT.
Just KT. Do you see why? So first you can bring down the exponent to the front. And then what is ln e? That's 1, right? Okay. So we have ln t minus a all over c is equal to kt. And then I guess you can see what the last step should be, right? Which is what? Divide by t, right? Okay, so t's cancel. And so what do you have? So we have ln t minus a all over c, and then everything over t is equal to k, right? Okay, or if you want to write it in a slightly nicer way, what can you do? 1 over t times ln t minus a over c equals k, right? Okay, we just like wrote 1 over t to the front of the numerator. Okay, so either way. Okay, so notice that this is kind of the same equation that we have worked like 1,000 times yesterday, but it feels extra tougher because of like 4 or 5 letters floating around. Okay, but the scheme remains the same. So now I guess you can guess what part B is about. So this one is exponential equation. So part B will be log equations. So R is equal to P plus K ln T and isolate T. Okay, so now what is the first step? To get T by itself.
Subtract P.
Minus P first, yes. Okay, so minus P. So we get R minus P is equal to K ln T. Okay, and now what? What is next?
Convert the right side into an exponent.
Not yet. We need to do something before that.
Divide by k.
Divide by k, yes. Okay, and what's the reason? So this is similar to this equation. Okay, so what do we have to do? Isolate the log on one side. And what does that mean? Divide by what's in front of the log, which is k. Okay, so divide by k. So what do you get? R minus P all over K is equal to ln T. Okay, then we have the isolation of the log. Okay, and then what's the next step? Okay, so now we have to, yes, convert this into exponential form. Okay, what does conversion mean? Remember, so ln T is same thing as what? Log base E, right? Okay, so what does that mean? Base goes to the base, so what's the base here? E. Okay, and I guess I should write this on the next column. So E here, which is the base. And then what is the exponent? It's the result of the log, right? And what is the result? This weird fraction, right? So E to the R minus P over K. Okay, so we took care of that. We took care of that. So what's the only remaining thing? T, right? So equals T. Okay, and now, are we done? And how do we know whether we are done or not? Is t isolated? Yeah, right? Right there. And the other side doesn't have any t. So what does that mean? That's it. Okay. So basically, we just had to convert this into exponential form, and then the answer just pops up. Okay. So now that's part B. And now the last problem. Okay, I don't know. So hopefully you like this word problem. It's not that hard. Okay, so apple pie, and this is the name of the company. And don't try to Google with this company name because you will not find any. So apple pie makes pies, and it's electronic pies, so it's kind of powerful. Okay, yeah. You might be in trouble if you eat these pies. Anyways, so the number of pies made since 2009 can be modeled by the function f of t equals 20.57 ln t plus 10.58, where t is the number of years since 2009. Estimate the number of pies sold 2 years ago, 2018. Okay, so now here, what does 2018 represent? The t or f of t? So in other words, do we plug in something into t, or do we set this whole thing equal to 2018?
We plug something into t.
Okay, what do we plug in? 2018?
So it should be 9.
Should be 9, yes. Do you see why? Because t is the number of years after 2009, right? And that's the year. So t is equal to 2018 minus 2009, so that's 9. And we plug this into t. Okay, so what do you get? 20.57 ln 9 plus 10.58. Okay. And now what? So there can't be this many pies, right? I mean, like, we don't know what this thing is. Like, that's just a number. So what do we do next? I mean, like, when you go to like any grocery stores, you don't say, give me 20.57 ln 9 plus 10.58 pies, right? You don't ever say that. Yeah, because then people think you are kind of a little bit crazy. So what do you do next? It's quite simple. Like, there's no fancy thing here.
You set it equal to 0 and solve.
It's not even that. Remember, you don't ever say, give me 20.57 ln 9 plus 10.58 pies, right? So it's like same thing as give me 3 plus 2 pies. Like, you don't ever say that, right? So what do you do? Simplify this. And how do you simplify? What's the only way to simplify?
So
Yeah, how? How? How?
Convert it into exponential form.
Say that again?
Convert it into exponential
Oh,
form.
no. Like, it's too fancy. Like that's the first syllable of the word.
Combine like terms.
I think you're thinking too hard.
Use a calculator.
Indeed, right? That's the only way, right? Yeah, remember, you don't ever say 3 plus 2 pi's. You have to get a concrete number, right? And what's the only way? Of course, calculator. Yeah, right? We are trying to avoid this nice technology, and then eventually that gives trouble to people, right? Anyways, so it was so simple that people sometimes don't know it. That's okay. 20.57 and then times ln9 plus 10.58. Okay, so you should see this decimal. Okay, so you should see this decimal, which is 55.77690356 and so on. Now, is that it? So this company sold 55.77690957 or 56 pies. What's the answer? So I guess it's quite easy to guess what the answer should be. It's either 55 or 56, right? Which one is it? 56, yes. And why do we have to round up instead of rounding down? Because if we round down and get 55 pies, then that is a little bit short of this decimal, right? So what does that mean? What does that mean? Since we have to get a whole number, and this is over 55, we have to round up, right? So the company has to produce one additional pie, right? Okay, because they have to at least satisfy this number, and the only way to satisfy is just make another pie, right? Okay, so there we go. Okay, so that's the end of 4.5, and in fact, that's the end of exam 4 materials. Okay, so that's that. And now the calculator is out. So we are not gonna see it again. Well, I mean, like you will see it tomorrow, but there is no calculator section basically. Okay. So now the last section of the course. Woohoo! The last section is 5.6. Okay, so now here it says linear, nonlinear systems of inequalities. Oh, okay. So now we saw systems of equations before, but before we study systems of inequalities, we have to look at the inequalities first. Okay, now you might say, well, oh, so we have seen inequalities before, like back in chapter 1. Well, yeah, but that only had one variable x. Now, what about here? Inequalities of x and y. Okay. And then the thing is, we can graph it. Now, when we had just one variable x, graphing inequality means graphing on the number line. Now, what if we have two variables, x and y, graphing on the xy plane? Okay, so again, before we study the systems of inequalities, we first have to look at how to graph a single inequality in terms of x and y. So inequalities in x and y have the form ax plus by is greater than c. Okay, so basically, if we had equal sign here, equal sign, then what does that mean? That's a line, right? Okay, but instead of equal sign, we will have some kind of inequality symbol. And quite obviously, we may see other inequality symbols as well. Okay, so how can we sketch the graph of this inequality? okay, in X and Y. So here is the scheme. Okay, so scheme to graph a single inequality. And maybe you have seen this scheme before or you haven't, or maybe you saw it but you forgot, but that's okay. So like I said before, if we had an equal sign right here, then the graph is a line, okay? So suppose that was the case, okay? So pretend that we had an equal sign and then sketch the graph of the resulting equation. And again, what does that mean? The graph will be a line, right? We know it, okay? So how do you sketch the graph of a line, of any lines? You need at least 2 points, right? Remember that? And mostly X and Y intercepts work, right? And remember when they don't work, when they involve fractions. Okay, so what do you do in this case? Find yet another point, right? Okay, so since we saw this scheme in chapter 2, I'm not gonna elaborate this again, but that was the case. Okay, now, one thing to be careful with. Number one, if you have less than or greater than inequalities, you put a dotted line. Okay, now for the other two inequalities, so less than or equal to or greater than or equal to, so whenever your inequality deals with equal to part, you put a solid line. Okay, and now number 3, plug in 0, 0 to the inequality. Okay, not the equation. Okay, so what does that mean? You plug in x equals 0 and y equals 0. And now, the good thing about this origin, 0, 0, is it serves as a test point or a representative of the region. Oh, okay. So now, what does this region even mean? So that is kind of a bit unclear at this point. But once we do the problems, you'll see what I mean by the regions. Okay. So it serves as the test point. And now, you will get one of these two statements. Okay, so if you get a true statement, when you plug in x equals 0 and y equal to 0, you shade the region that contains this point, which is the origin. Okay, so you shade the region that contains the origin. And if you get a false statement, you don't ever say no solution. You still shade. But what kind of region needs to be shaded? Whichever region that does not contain the origin. Okay. So in short, what is the common characteristic of graphing inequalities in X and Y? You are shading some region. In fact, that was the case when you had to graph the inequality of just one variable, right? Like on the number line, you shade some region, like here, from this endpoint with this open or closed dot, right? Okay, so same thing, but we are extending our concept on XY plane. Okay, so can I go to the next page? Okay, so now let's work on these two problems. So graph negative 4x minus 3y is greater than or equal to 12. Okay, so first thing first, we have greater than or equal to, and we know the graph is a line. What kind of line is it? Dotted or solid?
Solid.
Solid, right? Because we have greater than or equal to, right? Yes, okay. So we will have a solid line. Okay, so first, what do? Well, pretend that we had an equal sign. So that means negative 4x minus 3y equals to 12. And then we have to sketch the graph, right? Okay, so how do you get the graph? We need 2 points. And I said mostly the x and y intercepts will work fine, right? Okay, so what does that mean? Find the 2 intercepts. Now, how do you find x-intercept? Set y to 0. Remember that? Okay, so what do you get? Negative 4x is equal to 12, right? So x is equal to what? Negative 3, right? And now, what is the ordered pair representation of this x-intercept? Negative 3, comma 0, right? And now, is this a good point? And what do I mean by a good point? Can we use it to graph? And the answer is yes, right? Why? Because there's no fraction. Okay, and then the y-intercept. So that means set x to 0. So what do you get? Negative 3y equals to 12, right? And so y is equal to negative 4. Okay, and whose ordered pair representation is 0, comma negative 4. And now, is this also a good point? Yeah, no fraction, right? So we can also use it. Okay, so now going back to this scheme here. Okay, so we did step number 1, and we did step number 2 as well. And now what do you have to do? Plug in 0, 0 to the inequality. Okay, and we will see either true or false statement, right? Okay, so now we plug in 0, 0. Okay, so plug in 0, 0. So again, this means x equals 0 and y equals 0. Okay, so what do you get? So remember, you are plugging in these 2 values into here, okay, to the original inequality, not the equation. So what do you get? 0 minus 0 is greater than or equal to 12. Okay, so what does that mean? 0 is greater than or equal to 12, right? And now, is this true or false? That's false, right? Yes. Okay, so that's false. So what does that mean? This means we will shade whatever the region means, as you will see in a minute, shade the region that does not contain the origin, right? That does not contain the origin. Okay, so now let's graph. Okay, so graph. So here is the xy plane. Okay, and negative 3, 0 is the x-intercept, so negative 3, 0. And then 0, negative 4, so that's right here. Okay, and remember our line is a solid line, so that means we get this, right? Okay. Now, here at this point, do you see the regions? Now, please don't say, oh yeah, I see this triangular region. That's not the correct region, okay? What do I mean by the regions? The region means XY plane is divided into 2 regions by this line. And what are they? Above the line and below the line. Okay, not this triangular region, okay, or this first quadrant or so on, okay. So above and below, there are two regions. And now, does any region contain the origin? Where is the origin? Here, right? Which is where? In the above region, right? But remember, we didn't get a true statement for the origin. So what do we have to do? Shade the region that does not contain the origin. So what does that mean? Shade below. So that's the answer. Okay. And again, be careful with what kind of equation you are asked to graph. Okay. So for example, if you have to graph the line negative 4x minus 3y is equal to 12, okay, then your answer has to stop at right here. Okay, that's it. You don't ever shade. But if you have something like this, then you need to shade. Okay, so be careful whether you are given an equality sign or inequality sign. Okay, inequality sign means you need to shade some region. Okay, so be careful. Okay, so now part B, 3x minus 2y is less than 6. Okay, so now here, what kind of line are we gonna see? Solid or dotted?
Dotted.
The dotted this time, right? Because we don't see equal to part in our inequality, right? Okay, so number one, pretend that we had an equal sign, 3x minus 2y equals 6. And now we have to graph it. Okay, so that means we need the 2 points, x-intercept and y-intercept. So y-intercept, set x to 0. So what do you get? Negative 2y equals 6. And so y is equal to negative 3, right? Okay, so this means the point 0 comma negative 3, which is again a good point. Okay, and then x-intercept. So this means set y to 0. So we get 3x is equal to 6, so x is equal to 2. And so the x-intercept is 2, 0, which is also a good point. And now, plug in the origin. Okay, plug in 0, 0 to the inequality, remember, so right here. Okay, so that means set x equals 0 and y equals 0. So what do you get? Just 0 and then less than 6, right? Is this a true statement or false statement? Yeah, that looks good, right? So that's a true statement. So what does that mean? Whichever region contains the origin, we have to shade it, right? Okay, so this time we shade the region that contains the origin, okay, whatever that is. Okay, so graph. Okay, so the y-intercept is at 0, negative 3, so 1, 2, 3 down. And then the x-intercept is at 2, 0, so here is 2. And now remember, we have to have a dotted line, so dotted line. Okay, like this. And then, where is the origin? In the above region. And we got a true statement for that. So what does that mean? We shade this time above region, right? Okay, so that's the answer. Now, does that mean the origin will always be in the above region? No, because what if your line was something like this? Okay, then the origin is in the below region, right? Right there. Okay, and what if you get a true statement? You'll shade below region, right? If you get a false statement, you'll shade above region, right? Okay, so you never know where the origin will be. Okay.
What happens if you get a graph that goes through the origin?
Ah, good question. So if you get a line that goes through the origin, so something like this, then can you use the origin as the test point? And the answer is no. Okay, and actually I was going to say about this, but I'm glad you asked this like way earlier. So in that case, you cannot use the origin as the test point. So what do you have to do? You have to choose some obvious points that lie completely inside in either region. So maybe here you can do like maybe 1,2, or this is like what, 3,1 maybe, or maybe you can choose something like this, like -1,1. Okay, so going back to our scheme here, okay, as a side note, if 0, 0 is on the line, then unfortunately you just have to look at your graph and pick an obvious easy point that lies either above the line or below the line. Okay, so in other words, pick an easy point that lies above the line or below the line. Okay, so here be as easy as possible, like 1,1, or maybe you can do 1,0 if that's not on the line, or -1, -1. Okay, so something like that. Yeah, but good question. Okay, so now, any questions on getting the graphs of the single inequality? Okay, so once again, your goal is to not only get the correct line, either dotted or solid, and then shade the right region. Okay, so why do we need to know how to graph these single inequalities? Well, because systems of inequalities only has one more step. Okay, and also we may see non-linear cases. Okay, the scheme is slightly different, but it mostly stays the same. Okay, so what is the scheme of graphing the systems of inequalities? Okay, so here we'll see linear and non-linear cases. Now, obviously, which one is easier? The linear inequalities are easier. Okay, so here is the first case. So what's the scheme? And I think I have mentioned this in the past. So did I say that I'm running out of ink in my printer? So that's why my like this box here shows both orange and pink colors, but yeah, it's not a big deal, right? I can just wait to replace the ink, like it's not the urgent task. Anyways, so here, what's the scheme? So here you'll see two linear inequalities. So what do you do first? Graph each linear inequality, which we just saw, okay? And remember to shade the regions or the right regions, okay? Then you'll see a region for one inequality, and then you'll see another shaded region for the other inequality. And at some portions on the xy plane, there will be the overlaps. Okay, so what is the step number 2? Find the overlaps of the shaded regions. Okay, so that overlap is the key. Okay, so once again, you shade, or you get 2 shaded regions, and then you have to find where they overlap. Okay, now, what's the scheme for sketching the graph of nonlinear system? So, as you will see here, the scheme is mostly the same as the scheme of graphing single linear inequality. Okay, so what was the step number 1? Pretend that we had an equal sign and sketch the graph. Okay, then what is different compared to graphing single linear inequality? Well, this is non-linear, which means it doesn't have to be a line, right? So what are some options for these graphs? Well, you will first see lines, okay? So that's an option. But not only that, you will see parabola, which is a nonlinear case, right? And also you will see circles, okay? And you may also see exponential function, whose graph is what? Like this one or this one, remember that? Increasing curve or decreasing curve for the exponential function, which is something that you have to know for tomorrow's exam, right? Yeah, okay. Yeah, I think I told you too much, so whatever. Okay. Okay, so either lines or parabolas or circles or exponential curves, okay? So anything is possible. And then one thing that we have to be careful with, less than or greater than inequalities, what do? We get dotted, and this time graphs, okay? And what's the difference? Earlier, I said dotted lines, and I don't say that, or I cannot say that here because we will see nonlinear graphs, okay? So we may see dotted parabola, we may see dotted circle, we may see dotted exponential curves, okay? And then for less than or equal to or greater than or equal to, we will see solid graphs. Okay, so same thing. And then what was the next step in graphing single inequality? Plug in the origin, right? Exact same thing to the inequality, which serves as a test point, representative of the region. Okay. And then we still get true or false statements. So guess what happens in each case? If you get a true statement, you shade whatever region contains the origin. If not, you shade other region. Okay, same thing. Shade the region that contains the origin. If not, shade the region that does not contain the origin. Okay, so again, our common goal is to shade. Okay. And now, going back to, who was it? Kendra's question earlier. What happens when 0, 0 lies on the boundary? Which means on the boundary of both or either graphs. In that case, what do? Well, just do the same thing. Pick an obvious, easy point. pick an easy point. Okay, so once again, be as easy as possible, such as like 1, 1, 1, 0, -1, 1, things like that. Okay, or you can do like maybe 1, 2, but try to avoid like 1, 10. Okay, because that might be a little bit too big. Okay, pick an easy point that lies completely inside in either region. Okay, and then plug that into the inequality. Okay, so exact same scheme, but the only differences are what? We are not dealing with just lines this time, okay? And then we may see like other non-lines or like non-linear cases, like such as parabola, circles, and exponential curves and things like that. But that does not mean we will not see any lines for the nonlinear system, because even for the system to be nonlinear, we may see one equation to be linear, right? And as long as the other equation is nonlinear, we are good to go. Okay? So that's the scheme to graph systems of inequalities. Okay, so can I go to the next page? Yeah? No? Yeah? Okay. So there are only 3 problems here in these systems of inequalities. So number 2, graph the solution set. X minus y is greater than or equal to 1, and x plus y is greater than or less than or equal to 4. Okay, so now, do we have nonlinear system or linear system here? So in other words, are you gonna see like parabola or circle or exponential curves as part of either equation, or we'll see just lines? We'll see just lines, right? Okay, yeah, because there's no x squared or y squared thing, right? Yes, okay. So now, the first line, is that a solid line or dotted line? That's a solid line, right? Yeah, okay, so that's one is, or the first one is a solid line. What about the second line? Is that solid or dotted? Another solid, right? Okay, another solid. Okay, so first, what do? Well, we have to graph each inequality, okay? And then we have to find their overlaps of the shaded regions, right? So let's graph the first one. X minus y is greater than or equal to 1. Okay, so remember what we do here. Pretend that we had an equal sign. So x minus y is equal to 1. Okay, and then we just find the 2 points, right? Okay, so now the 2 points. So x-intercept. So here we set y to 0. Then what do we get? X is equal to 1, right? Okay, so it passes 1, 0, which is a good point. And then the y-intercept. So that means x is equal to 0. Okay, so then what do you have? Negative y is equal to 1. So y is equal to negative 1, right? Okay, so that means it passes 0, negative 1, which is also a good point. Okay, and now, what do we do? Plug in the test point, right? 0, 0. Okay, to where? To this inequality. So what do you get? 0 minus 0, which is 0, is greater than or equal to 1. and this one is obviously false, right? Okay, so we shade whichever region, either below or above the line, that does not contain the origin. Okay, so sketch the graph. So what do we have? 1, 0 is here, and then 0, -1 is here, and we have a solid line. So we have this, right? And then 0, 0 is above the line, and we got a false statement there, so we shade below the line, right? Okay, and now do the same thing for the second equation. So x plus y is less than or equal to 4. Okay, so first we pretend that we had an equal sign, and then x-intercept. So we said y equals 0, and that means x is equal to 4. So that means the x-intercept is at 4, 0, which is a good point. And the y-intercept, set x to 0, and we get y equals 4. So that means 0, 4 is the y-intercept. Okay, and then plug in the origin. So what does that mean? Plug in the origin into here. So we get 0 plus 0, which means 0 less than or equal to 4. This one is a true statement. Okay, so what do you get? So 1, 2, 3, 4. That's the x-intercept. 1, 2, 3, 4. That's the y-intercept. And we have another solid line. So that means it's this one. It's this one. And then 0, 0 is below the line, which we got a true statement there. So we shade below line. Okay. So we got the two shaded regions, and now what do we have to do? Find their overlaps. Now, here at this point, it's tough to find where they overlap. So what do? Let's sketch both lines on the same xy plane. Okay. So now, what do we have? So here's the xy plane. Okay. And then the first line, so it passes 1, 0, and then it passes 0, -1 right there. Okay, so that was the first line. And then the second line, okay, so it's just this one. Oops, something like this. Okay. And now, where do we shade? So both are below lines, right? Okay, so that means here and here. Now, do we see any overlaps? Where is the overlap? Here, right? Okay, so what is the final answer? The final answer is this, and then this, and then you shade this. Okay, so that's the final answer. Okay, so when you do your homework over this section, when you sketch the graphs of systems of inequalities, what you have to do is do all of these by hand up to this point. And when you put your answer on the homework, so that means when you sketch the graph, you have to sketch this line, and then use the shading tool, which kind of looks like paint, like you'll see some kind of like cylinder thing with the like yellow liquid inside. I mean, like that's the kind of picture how it looks like. And you shade this below kind of like triangular-ish region here. Okay. So up to the final answer, you just do it by hand, and then for this part, you have to use your computer. Okay. And now part B, x squared plus y squared is less than or equal to 4, and y is greater than x squared. Okay, so now hopefully you can notice that this is a non-linear system because of the squares, right? Now, first, what kind of graph are we gonna see? Is it solid graph or dotted graph? For x squared plus y squared is less than or equal to 4. Is it solid graph or dotted graph? That's a solid, right? Yes. Okay, and what about the bottom one? We will see the dotted graph, right? Okay, so now let's sketch the graph of the top one. Okay, so this means we pretend that we had x squared plus y squared is equal to 4. Okay, now, have we seen the equation of this type before? And if so, do you remember how the graph looks like?
Circle.
Oh, where is the center?
0, 0,
And what's the radius?
2.
Oh, good. Okay. So this is a circle with the center 0, 0, and the radius is 2. Yes. Okay. So we know how the graph looks like. Oops. Something like this, right? Oh my goodness, that's a perfect circle. I'm impressed to myself. Oh my goodness. I'm not a computer, but somehow, I think that's like kind of one of the most perfect circles that I've ever drawn. Anyways, I'm impressed to myself. Woohoo! Okay, so what does that mean? That's 2, that's 2, that's negative 2, and that's negative 2, right? Okay, so now, where is the 0, 0? So here, again, do you see the two regions? And what are the two regions? And this time it's not above and below the line, right?
Inside the circle and outside of the circle?
Inside circle and outside of circle, right? Yes, okay. So here we again see two regions, inside and outside. Okay, and where is 0, 0? It's inside the circle, right? In other words, it's not on the boundary. So we can use 0, 0 as the test point, right? Okay, so plug in 0, 0. Okay, to here, the inequality. So what do you get? 0 squared plus 0 squared, and what is that? Just 0, right? So 0 less than or equal to 4. Okay, that looks good. So what does that mean? We shade whichever region that contains the origin, which is the inside, right? Okay, so that's why we shade like this. Okay, and now graph the second one. So graph y is greater than x squared. Okay, so that means we have to look at y equals x squared. Have we seen this equation before? And how does the graph look like?
A parabola?
Okay, and where is the vertex? So it's a parabola. Where is the vertex?
0, 0.
At the origin, yes. Remember what vertex means? It's either lowest or highest point of the graph, right? Or the parabola. Okay, remember that? Yeah, so the graph looks like this. Uh-oh, by the way, why did I draw this dotted parabola? Is that a mistake by me? No. We had concluded earlier that we will see the dotted graph for the second equation, right? Okay, so our parabola has to be dotted. Okay, and now plug in the origin. Now, where is the origin? Is that on the boundary? Unfortunately, yes, right? So what do we have to choose? One point that is so obvious and it lies on like either within the parabola or above the parabola or below the parabola, right? So can you come up with, okay, so once again, 0, 0 is on the graph, so we cannot use it, okay? So can you come up with a point that does not lie on the boundary?
0, 1.
0, 1. Okay, so now where is 0, 1? Here. Okay, so that's 0, 1. Okay, so that's a good point. And now, so plug in 0, 1. So plug in 0, 1 to where? To here, right? To this inequality, okay? So what does that mean? We set x equals 0 and y equals 1. Okay, so we get 1 is greater than 0 squared. Okay, so what does it mean? In other words, 1 is greater than 0, right? Does this look good or bad? Looks good, right? Yeah, so that's a true statement. So what does that mean? Whichever region that contains 0, 1, we have to shade it, right? Okay, so now let's put everything all together. Put all together. So again, here's the xy plane. And then we have a circle with the radius 2. And that is a solid circle. Okay, and there we go. My circle this time looks awful. So, and now we have a dotted parabola. So that means it looks like this. Okay, and now we shade the inside circle. Okay, and then 0, 1 is above the parabola, which we got a true statement there. So what does that mean? We shade this, right? Okay, and now what do we have to find? Overlaps, right? Okay, so is there any overlap here? Yeah, so where is the overlap? Right there, right? Okay, and so what do we have to do? So what's the answer? So the answer looks like here's a circle, and then here is a parabola, and then this little region. Okay, so that's the answer. Okay. Oh, and by the way, when I wrote down the schemes earlier, did I write down find the overlaps? No, I don't think so. Oh my gosh, that's amazing in a bad way. Okay, so find the overlaps. I mean, like, I didn't write down maybe because I thought it was so obvious, but don't forget to find the overlaps. Okay, find the overlaps of the shaded regions. Okay, so anyways, so now we are done with part B. And then part C. Okay. So this time, what do you notice? We still have a nonlinear system, but at least one of them is a line, right? Okay, so in fact, the bottom one is the line, right? Okay, so now, first, the top graph. So this one is a solid graph, right? Whatever that is. And then the bottom one is a dotted line, right? Okay, so first one. So first we have y equals x squared minus 16. Okay, now, how does the graph of this look like? What kind of graph are we gonna see? Is that a circle? No. Is that some kind of curve? Yeah. Okay, so this one is a parabola, right? Because of x squared. Okay. Now remember, to sketch a parabola, how many points do you need at minimum? 3. Remember that? Yeah. Okay. So let's find the 3 points. And how are we gonna find them? So first, let's find the x-intercepts. Okay, so what do? Set y to 0. So you get x squared minus 16 equals 0. Okay, so now how do you solve this equation? So maybe you can subtract x squared. Okay, so you get negative x squared equals negative 16. And then cancel the negatives. So x squared equals 16. And now, does it remind you anything what to do next? Take the square root, right? So x is equal to what? 4, right? 4? Plus minus 4, right? Okay, so now, what does that mean? How many x-intercepts did we get? 2, right? At 4, 0, and negative 4, 0, right? Both of which are good points. And now, find the y-intercept. So what does that mean? Set x to 0. So what do you get? 0 squared minus 16. So y is equal to negative 16, right? Okay. So the y-intercept is at 0, comma negative 16, which is a good point. Okay. And now, the third thing. We have to plug in 0, 0. Okay, so now, what is one small issue? 0, 0 might be on the boundary. In this case, or in that case, we cannot use it, right? So let's see whether we can plug in 0, 0. Okay, so first, let's sketch the rough graph. Okay. So it passes 4, 0. So 1, 2, 3, 4, 0. And then negative 4, 0. Okay, so right there. And then 0, negative 16 is where? Like way down here, right? Okay, so how does the graph look like? Something like this, right? Okay, and it's a solid parabola. So where is the 0, 0? Oh, it's not on the boundary, so that's good, right? So when we plug in 0, 0, what do you get? So plug in 0, 0 into here. Okay, remember. So what do you get? 0 greater than or equal to 0 squared minus 16. And what does that mean? 0 is greater than or equal to negative 16. This one looks good, right? So that means we shade where? Above the parabola, right? Okay. So now we did the hard part, and now let's sketch the graph of the line, which is the second equation. Now, can I slide up this paper a little bit? Okay. So now go to the second line. So x minus y is equal to, oops, negative 4. Okay. So this is a line. So we need to find x and y intercepts once again. So x-intercept, set y equals 0. So that means x is equal to negative 4. So it passes the point negative 4, 0, which is a good point. And then the y-intercept. So set x to 0. Okay, so now what does that mean? Negative y is equal to negative 4. So that means y is equal to just 4. So it passes 0, 4, which is a good point. Okay? And now we plug in the origin. To where? Here, okay, to the inequality. So what do you get? 0 minus 0, which is 0, is greater than negative 4, which is a true statement. Okay, so we have to shade the region that contains the origin. Okay, so what does that mean? Okay, so here, negative 4, 0 will be somewhere here. And then 0, 4 will be here. And it is a dotted line. And 0, 0 is below the region or below the line, which we got a true statement there, so we have to shade below the line, right? Okay, so now we have the two shaded regions, and now let's put them all together. Okay, so first we have this parabola, which looks like this. Okay, and then, so here it's negative 4, 4, and negative 16. And then the line passes negative 4, 0, and 0, 4. So it looks something like, oops, dotted line. Dotted line, that's not a correct line. Okay, and where do we shade? Here and here, right? And now, are there any overlaps? Where is the overlap? Here, right? Okay, so what's the final answer? The final answer is, so again, it looks like this, and then this, and then this region, right? Okay, any questions on graphing systems of inequalities? Okay, guess what? We are done. Okay, so that's the end of the course. So for the rest of the class, Does anyone have any questions? Not only for tomorrow's exam, but also for the final or maybe the course in general? No? Okay. So one thing I want to mention about tomorrow's exam is, so I think I said earlier or like in the past that there will be 26 problems, but I was or I made a mistake. There are 27 problems. But remember, 5 of them are calculator only problems because it will say explicitly, write your answer in decimals, like up to, I don't know, 3 or 4 decimal places. Okay. But otherwise, none of the answers is in decimals for other problems, because you either get whole number or the problem is just multiple choice, which means, I mean, the calculator usage is not necessary, okay? So remember, you are allowed to use calculator up to 5 times, but there are 5 calculator only problems, so every other problems need to be done without the calculator, okay? So that's that. And